in today's presentation. Okay, so today's talk is mostly on this clip and yeah. So if I have to introduce myself, I have worked on large language models and also I have also worked on vision language models. Okay, so when it comes to large language model, I have worked with GPT series. I have worked with GPT-4V, which is a vision language model. Okay, and what generally happens in industry is so we have a tie-up, we have a partnership with OpenAI. So whenever OpenAI comes up with a new model, what happens is we have to jump in and we have to apply the model as per our use case. Okay, so if I have to tell you about one instance where I have worked with GPT-4o, so what we have done is we have used GPT-4o to create stories. Okay, to create stories out of only prompts. Okay, so if you go and see in Microsoft Designer, there is one page where you can create stories out of prompts. So you can give a prompt. For example, if you want to talk about large language model, or if you want to talk about vision language model, then you can do that. Okay. So what generally happens is in industry, we care about cost, we care about efficiency, and when it comes to industry, so there is also a responsible AI also comes in. Okay, responsible AI deployment safety board. So something bad should not come out. So, for example, there should not be any sexual content. There should not be any harmful content. So user can be a good user. It can be a bad user. So we should filter out those prompts. So for that we have guardrails. Okay, so guardrails are there at the input side, at the output side. Bad actors can come in any point of time and they will type in anything. So your prompt engineering should be in such a way that that you can extract the best of large language model as well as the vision language model, and you should be able to deploy the model. And once deployed, it should work flawless. Okay, so the latency should be small, latency should be less, then the accuracy should be good enough. And if you have written some prompt, so the large language model should be able to understand the instructions. Okay, so that's how people work in the industry. So whatever I'm telling is with respect to Microsoft Designer. So Microsoft Designer is one product which is very similar to Canva. So if you have used Canva, so similar to that, they have in Microsoft, they have a product which is Microsoft Designer, which you can use it to create birthday cards, you can create invitations, you can create posters with only prompts. Okay, so they have large language model, and then they have a something, for example, which can create images out of text. Okay, so there will be an image creation model. So image creation model it can be a DALL-E. It can be anything. Okay, so so let me start with this vision language model. So in vision language model, clip was a milestone. Let's see on that. Okay, so why vision language model? So before this, we had ResNet, we had BERT. So when it comes to ResNet, so ResNets were good with images. Okay, so ResNet CNN based. They were good at images, and BERT were good at text. So what are the limitations? So they had a fixed label set. So poor generalization to unseen categories. So for example, if you have trained your model on ImageNet, so it can only detect, or it can only do classifications to those classes. But beyond that, it will not be able to do it. Okay, so and BERT birds were very good at text, but not so good at on the image side. So we need to look at how we can do some kind of cross-model learning. Okay, so how that cross attention um, how we can fuse both the informations of images and text. Okay, so that's what vision language model talks about. And if you see single modality, if you just take all the images which is available in the internet or all over the world. So with that, you will not be able to get the what you call the artificial general intelligence. Okay, so you will not be able to get the intelligence, or if you have lots of what do you call lots of text, and you have trained your model, so even with that you will not be able to achieve uh, good reasoning capabilities with that. Okay, so what is the future? So future is how we can combine uh, text, how we can combine images, how we can combine other modalities like audio, how we can combine depth maps. So going forward, so these are the research areas where we can combine the things which are available to us. So we have to combine. So single modality is not good enough, so we have to look into other modalities. So it's going to be a multi-modal. Okay. So that's how we also, as a human, we also try to integrate vision plus language naturally, and that's how we get our understanding. Okay. So let's go. So what is a vision language model? So model that jointly learns from images and text. Okay. So if you see, um, so if you see here, so type of task which they can do. So one can use vision language model for image captioning. One can use it for visual question answering, image text retrieval, even open vocabulary classification. So this is important, open vocabulary. So for example, if you want to do some kind of object detection, or if you want to do some kind of image classification, then this open vocabulary is very, very important. So what we have seen is we have seen models which are trained only on ImageNet, or we have seen models which are trained only on Coco dataset. So they can do those tasks very well. So even image text retrieval. So even, for example, if you want to retrieve some images by using only text, for example, if you are looking for photo of a marriage, or photo of my graduation ceremony. So even that can be done with image text retrieval, and this is being used. Okay, so image text retrieval is being used in industry, and it's being used when it comes to visual question answering. So for example, GPT-4V, you can throw any image, and then it will give you, so it can give you, so you can ask any question. So for example, it can do object localization. So when it comes to object localization, so Florence V2, so even that model is very good at localization. So one can do zero shot segmentation. So for example, if you want to segment the cat, or if you want to do anything, so these models are very good at zero shot. Okay, so even if the model has not seen, but so it is able to do the inferencing. Okay, so yeah. And image captioning is an old research which is being continued, but going forward, if you see visual question answering, image text retrieval, and object vocabulary classification is something which is new, and it is being used in industry heavily. Okay, so let's So if you see, Clip was the milestone. Okay, so Clip, which came from OpenAI in the year 2021, it was a milestone, and after that, there has been numerous vision language model which has come. Okay, so Flamingo, Blip, Pali. Then in 2023, we have seen Blip 2, Cosmos, Lava, GPT-4V. So GPT-4V was when people were able to play with, for example, they have asked so many questions only with the GPT chat interface. Okay, Chat GPT. 2024, Gemini, Cloud, MM1, Intern, VL, Florence 2 from Microsoft. This is also so you can do object localization, you can do object classification, you can do OCR. So lot of things, all with the help of open vocabulary, which Florence V2 was satisfying. Okay, then we have Vila, Quen VL. So you see the interest of most. So the interest lies in vision language model, and going forward, the research is also going towards multimodality. Um, we want to include both text, images, and along with that, audio or maybe depth map. So how we can combine those things, and so the idea is to increase the general intelligence. Okay, so how we can make the model more and more intelligent. So how we can make the model learn new things. Just because you don't have enough text, you don't have enough images by which you will be able to increase the intelligence of the model. So that's when where people have thought that how we can combine the two. So Clip was a milestone. I would say a ImageNet moment, just like AlexNet. So Clip was the model when vision language came up. Okay, so so contrastive language image pre-training, so developed by OpenAI to connect text and images, uh, recognizes and categorizes without task-specific training. So this is one of the most powerful features of Clip. Is that it can perform zero shot. That's what I was talking about. So even if the model has not seen it during training, this Clip model is very good at zero shot. So it can recognize and classify images it has never explicitly been trained on. Okay, so yeah. So it also learns relationship between text and visual features, and that's very similar how we combine our senses. So I was talking about that how we can combine the multimodalities of the two, text and visual features. And you can also say this, that this is also a universal encoder for image embeddings. For example, if you want to search something, or if you want to do some kind of classification, image text retrieval, or anything, so these are very good at so Clip model. And you can use Clip for maybe for your use case, or for any other use case. You can do some fine tuning on top of that, and it can really do wonders for you. Okay, so and as I said, they were the first to pave the way for vision language model, and generative diffusion model. Clip has become so it has become the default backbone in modern multimodal architectures. Okay, so if I have to show you, so for example, DALI. So Clip and DALI, both of them came in the year 2021, and people were talking mostly about DALI just because it can create images. But in DALI also, they had used this Clip model. Okay, so why Clip? So over task-specific model like ResNet. So as I have told on this, so ResNet can only work on ImageNet. So it can work on ImageNet 1K or it can be very good at ImageNet 21K, but struggles with out of distribution. So, for example, if the classes are not known, then it does not do that well. Poor generalization. So generally, what happens is industry or most of the time you may not be working with these classes. So you need to have something which can generalize well. Okay, in industry also, so for example, if you want to do some kind of task, for example, background removal. So in background removal, if you want to test on so you can test on some number of images. It can be 100, it can be 1,000, or it can be 10,000. But beyond that, you cannot test on all images which are available on the internet. So what generally happens is, so you may be getting some classes. For example, you may be getting some 10 classes or 100 classes, and you will try to see how the model performs on those classes, and is it able to generalize well on unseen classes or not. That's how most of the model which goes into production, they are being seen in that way. So it should generalize well to unseen data. So if the model has not seen it during the training, but and there can be a chance when this thing happens. Okay, so it should generalize well to unseen data. So this is very important factor when you take the model to prod. So for example, if you have trained your model on academically available data set, but when it comes to taking the model to prod, when it comes to taking the model to user, you will be getting images which are clicked from high-res mobile phones, be it Samsung Galaxy or iPhone. So the quality of the image will be too good. So the model should be able to uh, do well on those cases as well. Okay, so what are the advantages? So trained on vast text image pairs from the web. So 400 million. So that was the time OpenAI, they have it's an web image text pair, so it has been trained on 400 million image text pair. So I'll be coming to that, how they have done that. And it's an contrastive symmetric law, so it aligns image text pairs. So something which is, for example, a image of a dog and a text with a dog, so they should uh, lie close to each other. And something which are if there is some mismatch, then it should lie apart. So that's how. And open vocabulary is something which I have talked about. So even if the model has not seen, it is able to generalize well, performs strongly on unseen categories. So zero shot is one good example. So zero shot classification, even if the model has not been trained on ImageNet 1K or 21K, I'll show you the examples that this model is very good at it. Okay, and so text-guided diffusion model. So, for example, text to image model also uses a clip. Okay, so so what generally happens in this clip? So what is the contrastive learning? So what is being done is you encode image as a vector, and you also encode text as vector. Okay, so you have a vision encoder. So vision encoder can be a ResNet, can be a vision transformer. Okay, and after that you get a embedding dimension of 512. The same thing, for example, this is an image, and you have a caption: man wearing a checkered shirt standing in front of in front of a truck. So vision encoder will give you some embedding. So this vision encoder can be a ResNet, can be a vision transformer. So they have trained with both ResNet and vision transformer. And the same is the caption is being passed through a text encoder. You get a embedding. So embedding is here in this case, they have used a 512 embedding dimension. So we want to represent the image embedding and the text embedding in the same embedding. space. Okay, so we will see. So vision encoder. So the vision encoder is a ResNet 50 convolution network, or it can be a vision transformer, and it outputs a 512 vector dimension. And the text encoder is again a 12-layer transformer with 63 million parameters, 8 attention head, and this is very similar to GPT-2. So 2021 is when GPT-2. So its architecture is very similar to GPT-2, same output vector dimension 5112. So both image embeddings and text embeddings are of 512. Okay, so clip architecture. So the one problem with clip is there is no cross attention, which is missing in clip. Okay, so that's when people have come up with if you go and talk about vision language model, so they talk about this cross attention, how the cross attention is happening between image and text. Okay, so for example, the query will be from your text, and key and values can be coming from the image part. And, uh, so so the parameters of both encoders are adjusted such that matching image text pairs have higher similarity scores than mismatches. So here we generally talk about cosine similarity. Okay. So yeah, so introduction to CLEP. So developed by OpenAI, it's trained on 400 million image text pairs, and objective is contrastive learning. So you have a text encoder, okay, and you have a image encoder. Text encoder is a transformer model, and image encoder can be a vision transformer, or it can be a ResNet based model. So it gives you embedding of 5112, and this is also an embedding of 5112, and we try to uh, take the cosine similarity between image and the text, and this is being done in a batch size. Okay, so here batch size is very important. So here what they have done is they have gone with a batch size of close to 32,000. Okay, so in that batch size, you can have images and you can have text. Okay, so you don't know which image corresponds to which text, and which text corresponds to which image, and that's how the model has learned. So the idea is to match similar things, is to match the similar things closer and dissimilar things away. That's how it has been done. Okay, so contrastive loss, how contrastive loss work. So here the image, the plot is for 2 dimension, but when it comes to clip, it will be in 512 embedding dimension. Okay, image of a dog and a dog text will lie closer to each other. Same thing, image of a cat and cat text will lie closer to each other, and some random image and some random text are there is no alignment, so they will lie apart. Okay, so it's a mismatch, so they will be away. Okay, so that's how these model have created a shared space for comparing vision and language model. Okay. Yeah, so this is very important. So if you see how clip works, so input batch of images. So we give in a batch of images plus caption. So you have these many classes, and a photo of it can be anything, and then you give it to a text encoder. You do the tokenization, and then after that you get the embeddings, and then you have the image embeddings, and you try to find out, you try to get the cosine similarity, and try to the basic idea is the dot product. So if it is very similar, so then what happens is, so for example, cosine similarity, if it is aligning well, so the what happens is you will have the highest cosine similarity. If it is not matching well, then they are apart. So you will be having a cosine similarity will be less. Okay, so it ranges between -1 to 1. Okay, so prompt a photo of a dog. So a photo of a dog, and so that's how you get a photo of a dog. So you have to. That's how the prompt engineering has been done. So one can play with this, a photo of anything, a photo. So if you just give dog and then text encoder, you give it, you pass it through a text encoder. You have tokenized it, and then you have got the embeddings, and you have an image encoder. Um, Pass it through ResNet or Vision Transformer, and then you do finally a cosine similarity. You will be getting some score, okay, some score. Uh, but if you add in some more words, so for example, a photo of a dog or a dog walking on the grass. So generally, what happens is they have tested with not with a single word, rather with bigram, okay, two words like that. In fact, more than that. Okay. So clip a loss function. So here we have used a contrastive loss function. Okay, and the idea is to keep the image and text in a shared embedding space. Okay, so this one is the similarity between image to text, and this is the similarity between text to image, and this is the temperature, which is nothing but which is a parameter, and this is the number of images, or the number of images with respect to text. Both are same. Okay, and then you try to get the loss function. Okay, you try to calculate the loss. So basically, it's a combination of loss function with respect to image to text and text to image, and then this is the normalization which has been done. And so this similarity is nothing but a cosine similarity between image to text and text to image, and then they have taken the log and done over the whole batch. Okay, and then finally divided by that. So this is how they have got the loss. So dot product or cosine similarity between all image text pairs in a batch. Okay. So clip training. So here what they have done is they have trained the model from scratch. So instead of taking the ImageNet weights, so they have not taken the ImageNet weight. Rather, they have trained the model from scratch. Okay, that's one thing which they have mentioned in the paper, and they also have used a larger batch size. So larger batch size here is 32768. Okay, so generally when we do trading, we work with a batch size of 3264 depending on. But here they have made sure that the larger batch size, they don't want, for example, you have image and you have text, but if you do it in a smaller batch size, so the kind of similarity and the kind of dissimilar, the model will be able to easily figure out. But if you keep it this large batch size, then the model is able to that then the model has to figure out which image corresponds to which caption. So that's how they have done. So that's the reason why they have kept this very high batch size. And they have also used a mixed precision training, so float 16 and float 32. So by default, it is generally one goes with 32, but they have used both float 16 and 32. So and contrastive loss choice, so efficiency in scaling with respect to web scale data, and what they have found is word for word. It is very slower to learn visual features. So I'll come to that part. Okay, so let me go to this applications of clip. So as I've talked about, if you want to do open vocabulary classification, these are very good at it. Okay, and text-based image retrieval. So for example, if you have lots of photos and if you want to filter out those, so even These are very good at it. So even what I've seen is even iPhone doesn't support this. In iPhotos, they doesn't support this feature, text-based image retrieval. So I'm not sure about the latest version, but this one is not available. Okay. But in industry, this text-based image retrieval is very common. Okay, and filtering and ranking web scale data. So that is so Lion is a humongous data set. So if you want to filter and if you want to rank which are good images and are they relevant to your use case or not, so you can do those. And then text carrier diffusion model, be it DALI stable diffusion. So it's being used there. And real world use case. So for example, with respect to search, with respect to recommendation, and you can do anything, any sorts of multimedia. Okay, so these are good things about Clip. So this one is something which I was talking about, Clip, zero shot image classification across diverse domain. So there are four data sets. So Food 101 is one, Sun 397 is one. It's another data set. YouTube BB is another data set, and Eurosat is specifically which talks about satellite images. Okay, so Food 101. So if you see guacamole, 90.1% ranked 1 out of 101. So a photo of a guacamole, a type of food. So even if the model has not seen it, the clip model is able to do this kind of classification. Okay, the same is with this. A photo of a television studio. So you may not find this a television studio in your ImageNet classes. Okay, so in spite of that, Sun 397 television studio 90.2% ranked 1 out of this. So then YouTube BP airplane person 89.0 ranked 1 out of 23 labels a photo of a airplane. So the model is able to correctly classify the image. Okay, and then annual cropland 46.5% ranked 4 out of 10. So here in this case, they are coming 4, but it is able to tell a centered satellite photo of a annual crop land. Okay, so this is the good thing about, so that's when people are talking about that clip should be your default model. So even if you have not if you have not done training, if you want to test something, so you can use clip for classification as well. Okay, so clip versus ResNet 101 performance. Okay, so if you see, so the performance of ResNet 101 and clip VIT large, so it is 76.2%, 76.2%, but here in this case it is 64.3. This is on ImageNet V2, 64.3, then 70.1. ImageNet rendition here, if you see the performance has dropped 37.7%. Here in this case, it is 88.9. So even if ImageNet sketch, so even if the model may not have seen the sketch, but just because as the model has been trained with contrastive laws where you have made sure that the image and text which are similar to each other are placed in the same embedding space, and the things which are far apart should be are dissimilar should be kept far apart. So here in this case 60.2%, and here in this case ImageNet adversarial, very difficult for ResNet 101 to do. So 77.1%. So if you want to do some kind of classification, so one can use this. Okay. So let's come to the data set. So the good thing about CLIP is that the model has been trained on 400 million image text pair. So CLIP, so they have not done anything new. So if you have followed, so people have worked with images, and people have also worked with text, and they have also tried to combine, but this is the time when they have trained the model on this humongous data. Okay, 400 million. image text pair collected from public internet sources. So what they have done is they have 5 lakh queries, and how they have chosen those 5 lakh queries. So here we are talking about 5 lakh queries. So we have seen ImageNet 1K and ImageNet 21K. Here it is 5 lakh queries. So based on all words occurring, which is greater than equal to 100 times in English Wikipedia. The 5 lakh queries have appeared greater than 100 times in English Wikipedia. So these are those queries, okay? And they have made sure that for each query, there are 20,000 pairs per query. So that means 20,000 image and text pairs for each of the queries. So 5 lakhs into 5 lakh queries, and for each of the query, they have these 20,000 image and text pairs. Okay. So training time. So largest ResNet based this one. Uh, RN50 X64 clip was trained on 18 days on 592 V100 GPUs, and largest VIT based clip took 12 days on 256 V100 GPU. So this is how the training time, and that is where they showed the power of vision language model. So that is when they have combined both vision and text. So before this, before this, what was happening? Only people were just talking about large language model, but nobody was talking about vision language model. But this is when they have come up with vision language model, and people also, even industry also, they also know that you need to combine the two modalities. If you don't combine, then you may lose, just because you don't have those many um, data sets, those many images, or those many text to train your model. Okay, so that's how. So what are the limitations when it comes to clip? So data bias is one. So just because as it has been taken from internet, those 400 million image text pairs, so you can have gender, you can have race, you can have stereotypes, some kind of stereotypes which can be pushed into your model. So gender is one thing, race is one thing, for example. Um, so it can be anything. Okay, so this data bias is something which industry cares about. For example, uh, mm, responsible AI, which I was talking about. So companies, they care about this kind of responsible AI. If you type in something and something bad comes up, so that will be available on the internet. And so big companies, they generally care about this. So there should not be any kind of biasness. So even if there is a biasness, it should be means they should be able to handle it gracefully. Okay. It should not come out. So with guardrails, which is on the input side, on the output side, it should be able to they should be able to handle it. Then surface level alignment, so it does not deeply understand text or images. So for example, if you have some bird species, or if you have some model of a car, okay, so it does not go into that intricate details. Okay, so that is also one thing. And computationally expensive, so this is something which is understandable, only big companies can do. And so limited reasoning ability, so struggles with compositional or relational queries. So when it comes to that, what I mean is it struggles with counting of objects. So in fact, nowadays also, so for example, there are data sets which are primarily designed to count a number of objects in an image. For example, object count is one feature. When you try to deploy a text to image model, so that model should be able to do, for example, draw or create an image with 4 apples lying on the dining table or on a fruit basket. So it should be able to create those many apples on your fruit basket. And even there is one left and right. So for example, the spatial relation, for example, draw or create an image of a water bottle behind the fruit basket. So all these things are something spatial relation, which is very difficult for any model to understand. Even now also, uh, there are data sets and even papers. If you go into text to image model, how they do the benchmarking of text to image model. So object count, then this spatial relation, left, right, or on top of it, or inside, or even comes to aesthetic prompt alignment. So these are being taken care. So yeah, so that's where they fail. Okay, and sensitive to prompt engineering. So prompt is something which is very, very important, even for large language model and even for this vision language model. Okay. So, and even one thing which I have seen, which I have heard, is that this clip does not do well on MNIST dataset. Okay. The future of vision language model, in fact, the future has grown. So we have seen Gemini 1.5. So we have Lava. So Flamingo was a few short vision language model for reasoning with sequences. And then you have Blip and Blip 2, Bootstrap pre-training with vision language modeling with reasoning capabilities, and this is one variation, SIG LIP clip variant with sigmoid loss, more efficient and robust. Okay, so these are some of the variation. In fact, this could have been more. In fact, more and more models are coming, and along with that, they are also the industry is also looking at how the model can fit into your smartphone, or it can fit into any edge device, or there can be applications with respect to drone, or there can be applications with respect to satellite imagery, or maybe with respect to defense. So that's where the game is being played. Okay, so it should be able to work well on web images, no doubt, but it should be able to do more than that. Okay, so when it comes to, for example, if you want to give some kind of intelligence to your robots, then it should be very good at this vision language model. Okay, so so that is this is when I've just covered one Flamingo model. Okay, and if you see, these blues are the pre-trained and frozen model, and this one is trained from scratch. So this is a photo of a dog, and this is a photo of a cat. You pass it through a vision encoder, which is pre-trained, which is frozen, pass it through a persevere resampler. Okay, and so and this is where they what they have done, interleaved visual text. This is where they combine the visual data and the text data. So this is a very cute dog, and this is where it should come up with. Okay, what should be this, and this is what the model is able to come up with. This is a very serious cat. Okay, so this is the process text. So you have a image, then you have this is a very cute dog, then you again have, you pass it through, you again added an image, and you are asking it to complete it, and you have the language model blocks, and finally you get the text. Okay, a very serious cat. Okay, so yeah. Mm, okay, so beyond clip trends and closing, so as I've talked about multimodal foundation model, so people are now talking about how we can, means GPT-4V was one for vision. Gemini or Cosmos 2. So people are now going beyond this video, audio, text, then depth map, and more than that. Okay, so how we can combine and how we can do it with less data hungry training, improve reasoning capabilities, how we can improve the reasoning, as I was talking about. Counts of objects or the spatial alignment. So these are some of the things which should be means one can work on how we can improve safer and bias control vision language model. This is very, very important just because everything is being trained from internet data. So if you can control the safety aspect of it, for example, with respect to suicidal thoughts or self-harming or violence, or maybe with respect to even jailbreaking. For example, there are bad actors who can try to get bad things. They can hijack the 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 prompts of the large language model or the vision language model. So how we can have that safety bias. And as I've told you, CLIP was the ImageNet moment for multimodal learning. So I have just discussed the CLIP, but if you want to go deeper, one can go into the survey papers of what is being done and how the multimodality is being added to these vision language model or multimodal foundation model. But going forward, people are talking about how can we fit this model into smaller edge devices, okay, be it your phones. So yeah, how we can do that. So that's one thing which people are working. So be it in companies like Samsung or anywhere. So even Samsung, they would love to do it on edge instead of relying on the cloud giving you data. So data will go to the cloud, some kind of large language model is running on the cloud, and then it will give you the data. So there is a latency which is involved. What if we can do that on the edge, on the mobile device itself? So small vision language model is something which people care, and that's where the industry is also going towards. Okay. Yeah. So with this, I will end. If you have any questions, I would love to take those. So there are some questions. Maybe we can take those. Uh, where is that? Web interface, I'm not getting. Hello, am I audible? If there are any questions, maybe if you can, okay, I'm not able to get the text. Hope I'm audible. Mm, if someone can read the question, it would be great. Just because I'm not able to get the text. Okay, yeah. I'm not getting the text option. Yeah. So, uh, so Babita has asked how effective is SSA? So I didn't get what is SSA?
Sir, questions will be in the chat box.
Okay, so yeah, I got the question. Uh, when it comes to video parsing, okay, so there are models which are available. Okay, so there are a lot of research, and in fact, newer models have come which can do video editing on the go. So, for example, you have if you have taken if you want to do some kind of video editing, so it can find out the best shots of your multiple sources from multiple sources of camera, and it can do video editing. So all the things can be done. So there are VLMs which can do. So there are VLMs which can work on it. Okay, so um, so yeah, yeah. So there is one important means a very interesting question. Can large-scale pre-trained VLMs be distilled into smaller? Yeah. So this is one thing which industry is being doing, and they have been successful. Okay. So distillation is something which is being done, and along with that, with respect to if I have to say with respect to how you store the data, okay, with respect to the floating point, even they have gone till means INT8, even with 4 bits also they have been able, and so that the memory consumption of the vision language model, and along with that, distillation is one thing where people have used distillation, where you have a student and you have a teacher model, and you have trained the student model taking the teacher model. So that distillation is also being done. So this is being done with respect to this one. Yeah. Can we use clip for normal image classification? Yeah. So when it comes to, for example, if you want to do some kind of classification, you need what do you call? You need some. So what kind of classification you want to do? So you need to do if you want to do some kind of zero shot. So that zero shot has to be there. Some text should be there. So what are we trying? What means what kind of classification you are talking about? Maybe Pooja Kapesh. Yeah, so if there are any, I can take, or I'll be free to take those in chat. Is there anyone available? I can hand it over.
Sir,
Yeah. Hello, Deepak. Are you there?
Yes, yes, sir. Yes, sir. I'm joining
Yes.
actually from the hospital itself. Okay.
Yeah, yeah.
So
So no problem.
I mean, your session was really useful because the topic itself is a very recent and very powerful technique in
Mhm.
computer vision. So I hope you have also answered all the queries I could see in the chat box here.
Yes, yes. I will try. I will try to answer
Yeah.
those
Yeah.
in
They
the
may contact
text.
you. I mean, they may drop email to you if they are having any additional queries and all.
Yeah,
So they,
sure. So,
so
yeah, so maybe the closing thought I would say, so small vision language model is going to be is going to be what you call people, means industry is caring about. They want, for example, if you want to deploy a model which can look into whether site workers are wearing helmets or not. So you don't need a very powerful large language or vision language model. You need a small model which can just look into whether the person is wearing any safety gears or not. So all these things, so which can run on some Jetson Nano or anything, any device. So that's
Yeah,
where the industry is talking about. It's going about. Okay.
yeah, yeah. So,
Okay.
so thank you very much for accepting our request and delivering wonderful talk on visual language models. So,
Yeah.
I,
Thanks.
on behalf of the Department of Computer Science Engineering and E and ICT Academy at MNIT Jaipur, would like to thank you.
Okay. Thank you.
Yeah, yeah. Thank you, Shah. Thank you so much, Shah.
Thank you. Bye bye.
Bye. Yeah. So we'll be having another session, participants. So that will be the last session of this FDP on diffusion models. As we all know, the importance of the diffusion models nowadays, right? So diffusion models are everywhere, right? So applications could be anything, but diffusion models are everywhere. So this is going to be the last session of our FDP, followed by a small, can say a validatory session. So I would like to request all of you to attend the last session as well as the validatory session. And the duration of this the validatory section will be, not more than 10 minutes or 15 minutes, right? Please, we want your feedback especially, right? So I would like to request all of you to kindly attend the session. Thank you. Thank you. Please wait for 5 minutes. The speaker will join with us soon.